They thought the systems were intact. They thought the defenses were holding. And for a few critical minutes, every report said the damage was contained. Then, the data started coming in. What followed wasn't a battlefield collapse, wasn't a breakthrough, and wasn't even an air defense failure in the way we usually understand it. It was something far more unsettling. A military network that looked operational, reported readiness, and yet could no longer function at all. No massive craters, no flattened bases, just silence where capability used to exist. This was not supposed to be possible. Not in minutes. Not across multiple regions. And certainly not without a single decisive breach. Until the footage emerged and revealed how an entire missile system didn't explode, it simply fell out of sync. Stay with us, because what you're about to see challenges how modern war is supposed to work and why the most dangerous failures often don't look like failures at all. Modern missile forces are built around the assumption that danger comes from the outside, from incoming strikes, enemy aircraft, or penetrating weapons aimed at launchers and storage bunkers. What this operation revealed is that the most decisive vulnerability often exists inside the system itself during moments that are considered routine and therefore safe. Maintenance windows are designed for efficiency, not survivability. During these short intervals, missile launchers are unfueled, safety interlocks are bypassed, cooling systems are opened, and hydraulic and electrical components are partially disconnected. In this state, the system is neither hardened nor redundant. It is transitional, exposed, and unable to absorb even minor disruptions. Ukraine's strike did not exploit a geographic gap or a weak defensive sector. It exploited a procedural gap, a period when operational logic assumes the absence of immediate threat. What makes this approach particularly dangerous is that damage inflicted during maintenance does not need to be spectacular to be decisive. A warped launch rail, a ruptured hydraulic line, or a contaminated fuel interface may leave the facility standing and the missile intact, yet render the entire launcher unusable for weeks or months. These failures cascade. A launcher knocked slightly out of alignment cannot safely fire. A damaged transloader halts reload cycles across the unit. A brief power interruption freezes diagnostics and delays alarms at exactly the wrong moment. None of this looks catastrophic in isolation, but together it paralyzes the system. The strike turns small physical effects into large operational consequences. By targeting maintenance windows, Ukraine shifted the logic of targeting away from place and toward time. Fixed defenses, hardened shelters, and layered air defense are optimized to protect locations. They are far less effective at protecting states of activity. Maintenance schedules, fuel cycles, and inspection routines create predictable patterns that cannot be armored or concealed. Once time becomes the targeting variable, even the most heavily defended sites become vulnerable not because they are weak, but because they must periodically expose themselves to function at all. In this sense, maintenance is no longer a support activity. It is a battlefield. Traditional thinking in warfare equates success with scale. The larger the explosion, the more decisive the strike appears. Flattened buildings, collapsed hangars, and towering fireballs have long served as visual proof of victory. This operation challenged that logic entirely. Instead of aiming for dramatic demolition, the attack was calibrated for micro-destruction. Small, tightly confined blasts placed where systems are most sensitive and least tolerant of disruption. The result was not spectacle, but paralysis. Explosions inside service zones did not need to tear structures apart. They only needed to push heat and pressure into spaces filled with exposed hydraulics, unsecured launch rails, open cooling systems, and live electrical control units. In those environments, even a brief surge of temperature or overpressure becomes catastrophic. What followed illustrates how modern military systems fail quietly. Launch rails warped by thermal shock no longer align within firing tolerances. Hydraulic fluid ignites, destroying actuators that cannot be replaced outside specialized facilities. Control electronics fail simultaneously, not because they were directly hit, but because they were never designed to survive sudden thermal spikes inside confined spaces. None of this leaves a dramatic crater. From a distance, the facility still stands. The missile launchers are still there. Yet functionally, the system is gone. Field repair is impossible. Replacement timelines stretch into months. Capability collapses without the visual cues traditionally associated with defeat. This changes how battle damage must be understood. Destruction is no longer measured by what is visible on satellite imagery or drone footage, but by what no longer works when the system is asked to perform. A base can look intact, and still be combat ineffective. Some will see this approach as overly restrained, arguing that leaving infrastructure standing invites recovery. Others may argue the opposite, that avoiding macro-demolition is precisely what makes recovery slower and more uncertain, because damage is buried deep inside the system's technical core. Both interpretations raise uncomfortable questions about how we define success in modern warfare. I'm curious where you stand on this. Do you think micro-destruction is more decisive than outright demolition, or does it carry risks we're underestimating? Share your perspective in the comments. One of the least visible yet most powerful effects of the strike was not physical at all, it was cognitive. Modern military systems rely heavily on rapid damage assessment to determine escalation, redistribution of forces, and defensive posture. In this case, Ukraine exploited that dependency by shaping how the damage appeared rather than how destructive it actually was. Early Russian reports described the incident as contained and limited. No major structures had collapsed. Missile stockpiles were not visibly detonating. From a command perspective, the situation looked disruptive, but manageable. That interpretation was not an accident. It was the result of an attack designed to fail quietly. The absence of large secondary explosions or widespread fires created a false sense of continuity. Facilities were still standing, communications partially functional, and some systems still powered. This outward normalcy concealed the fact that critical internal components had already crossed irrecoverable thresholds. Launch rails were misaligned. Hydraulic systems were compromised. Electrical control units had failed in ways that diagnostics could not immediately interpret. These are not failures that announce themselves dramatically. They emerge later, when systems are asked to perform under operational conditions, and simply cannot. That delay was decisive. While commanders focused on stabilizing what they believed to be a localized problem, the broader operational picture was already shifting. Defensive resources were not redeployed aggressively. Escalation thresholds were not crossed. Air defense posture adjusted incrementally instead of decisively. Every minute spent interpreting incomplete data was a minute Ukraine used to move the operation forward in other regions. By the time the depth of the damage became clear, the window for effective reaction had closed. This dynamic reveals an underappreciated vulnerability in modern warfare: the reliance on early assessments that privilege visible damage over functional integrity. When commanders cannot immediately distinguish between survivable disruption and systemic failure, decision-making slows and becomes conservative. In that space, initiative changes hands. Ukraine did not simply destroy equipment, it manipulated perception, forcing the enemy to respond to the wrong problem at the wrong time. In conflicts where speed and synchronization matter more than raw firepower, misreading damage is no longer a minor error. It becomes an operational weapon in its own right. The operation demonstrated a paradox at the heart of modern air defense. A system can perform exactly as designed and still lose the fight. In this case, air defenses were neither breached nor destroyed. Radar tracked incoming objects. Fire control systems generated solutions. Interceptors launched on cue. By every technical metric, the defenses worked, yet strategically, they failed. The reason lies in how saturation was applied. Instead of forcing a breakthrough, Ukraine forced commitment. Decoy drones were introduced in sufficient numbers and patterns to trigger full engagement protocols, compelling defensive crews to respond as if facing a major attack. Once that threshold was crossed, the system began consuming itself. Sensors locked onto targets that were never intended to survive. Operators shifted into high-tempo engagement cycles, prioritizing speed over discrimination. Interceptor missiles designed to stop high-value threats were expended rapidly against low-cost decoys that neither evaded nor adapted. Each engagement drew power, attention, and time into a closed loop. The defense was no longer shaping the battle. It was reacting to stimuli carefully designed to keep it busy. Importantly, this did not require overwhelming numbers. It required just enough activity to saturate tracking capacity and decision-making bandwidth. The strategic effect was exhaustion without contact. By the time the defensive posture stabilized, magazines were depleted, radar channels were congested, and crews were cognitively taxed. When real strike assets appeared later, they did not face a broken defense, but a hollow one standing, alert, and largely empty. This distinction matters. Destroyed defenses can be replaced or bypassed. Depleted defenses remain in place, masking their weakness while consuming time and resources to restore. This reframes how success should be measured in air defense operations. The question is no longer whether an incoming object was intercepted, but whether the system preserved its capacity to respond to what comes next. In this operation, interception became a liability rather than a success metric. The defenses did not lose because they were ineffective. They lost because they were too willing to engage, too responsive to signals that were never meant to be decisive. What stands out most sharply in this phase of the operation is not the exchange of fire, but the exchange of value. The drones themselves were simple, inexpensive, and never intended to survive. Their purpose was economic rather than tactical. Each decoy, costing less than $1,000, was engineered to provoke a response that would burn through interceptor missiles priced in the hundreds of thousands. This was not an unintended side effect of the engagement. It was the design. Ukraine did not merely attack Russian defenses. It attacked the logic that underpins how those defenses are sustained over time. In a matter of minutes, air defense units consumed resources that normally would be rationed across weeks of heightened alert. The critical point is that financial depletion unfolded faster than physical destruction. Launchers remained intact. Radar arrays stayed online. Crews were still at their stations. Yet the most important constraint, the availability of interceptors, was suddenly binding. Once magazines were emptied or critically reduced, the defense entered a different operational state, one defined by hesitation and conservation rather than confidence. Replenishment is neither immediate nor simple. Interceptors must be transported, authenticated, loaded, and integrated, all while under the assumption that another wave may arrive at any moment. That friction transforms cost into time, and time into vulnerability. This dynamic forces a re-evaluation of what winning looks like in air defense. Traditionally, success is measured by intercept ratios and protected assets, but those metrics ignore sustainability. A defense that intercepts everything today but cannot afford to intercept tomorrow has not solved the problem. It has postponed it. Economic asymmetry accelerates that reckoning. When attackers can afford to lose every asset they launch, and defenders cannot afford to engage every asset they detect, the balance shifts, regardless of technical superiority. There is no single correct interpretation here. Some professionals might argue that any intercepted target represents success, regardless of cost. Others may see this moment as evidence that economic pressure has become a frontline weapon in its own right. What is clear is that defense economics, once a background consideration, became an immediate operational constraint, one that shaped decisions in real time rather than in budget cycles. The strike made clear that missile power does not reside in the launcher, or even in the missile itself, but in the quiet systems that allow that missile to be fired again and again. Launchers are visible, mobile, and symbolically important, which is why they dominate public narratives and intelligence assessments. Yet without fuel distribution points, transloader vehicles, and reload staging areas, a missile force becomes a one-time instrument. Ukraine's targeting choices reflected a precise understanding of this reality. Rather than hunting for launchers protected by shelters and layered defenses, the operation focused on the ecosystems that sustain them. These systems are rarely redundant, rarely hardened, and often clustered for efficiency rather than survivability. Transloaders in particular represent a critical bottleneck. They are specialized, scarce, and essential for moving missiles from storage into firing configuration. When a transloader is destroyed, the missile it was meant to service effectively ceases to exist as a usable weapon, even if it remains physically intact. Fueling infrastructure creates a similar choke point. A launcher without fuel is not delayed, it is inert. Damage to pumps, lines, or pressurized reservoirs does not need to be extensive. Contamination, pressure loss, or thermal damage can halt operations indefinitely. Unlike launchers, these components cannot be quickly repositioned or improvised in the field. The result is a form of paralysis that is both efficient and difficult to reverse. Commanders may still count missiles on hand and launchers on the roster, but their ability to generate sorties collapses. Readiness reports become misleading. A force that appears numerically intact loses tempo, then relevance. This also shifts the burden of recovery upward. Repairing or replacing logistics nodes requires secure transport, specialized technicians, and stable rear areas, conditions rarely available during active conflict. By prioritizing logistics over launch platforms, the operation redefined the center of gravity in missile warfare. Strategic value moved away from the most visible assets toward the least discussed ones. Power was not removed through dramatic destruction, but through the quiet elimination of processes that allow weapons to function as part of a system. When infrastructure disappears, capability follows, often long before anyone notices the absence. The operation exposed a limitation that no amount of hardware modernization can fully solve: the human mind operating under extreme information density. Modern air defense systems are often described as automated, but in reality, they remain deeply dependent on human judgment, especially when conditions deviate from the expected. By flooding sensors with excess targets, the attack pushed operators beyond the boundaries of reliable decision-making. Tracking systems can follow dozens of objects, but prioritization, deciding what matters now, still depends on people interpreting incomplete, rapidly changing data under pressure. As targets multiplied, clarity gave way to compression. Radar tracks overlapped, speeds and altitudes varied just enough to prevent pattern recognition. Fire control systems began cycling priorities, dropping one track to pursue another. Operators were forced into constant reevaluation, a cognitively expensive process that degrades accuracy over time. In this environment, engagement decisions became reactive rather than deliberate. Missiles were launched on partial solutions, not because crews misunderstood the system, but because waiting for perfect information felt riskier than acting immediately. The result was increased interceptor expenditure with diminishing returns. This is where confusion becomes self-reinforcing. Each launch adds debris, electronic noise, and sensor interference, further degrading the picture operators rely on. The system does not fail abruptly, it degrades incrementally as human bandwidth is consumed. Stress, time pressure, and fear of missing a real threat compound the problem. Even highly trained crews begin to rely on heuristics. Engage what looks threatening, respond to the loudest signal, trust automated cues without verification. These shortcuts are not errors in discipline, they are natural responses to overload. What ultimately collapsed was not the machinery, but the decision loop. Sensors still detected targets, launchers could still fire, communications were still functioning, yet the coherence that binds those elements into an effective defense unraveled. By the time the system approached technical limits, it had already lost cognitive control. This suggests a shift in how vulnerability should be understood. Future conflicts may be decided less by who builds the most advanced systems, and more by who can push human operators to the edge of comprehension faster than they can adapt. Electronic warfare is often treated as a force multiplier, a way to dominate the battle space by denying the enemy information. In this operation, that assumption was turned on its head. As jamming intensity increased, it did not create clarity through denial. It generated chaos through excess. High-powered emissions flooded the electromagnetic spectrum, saturating not only enemy receivers but friendly sensors as well. Radar returns multiplied, folded, and echoed in ways that degraded, rather than enhanced, situational awareness. What was intended as a protective fog became a storm inside the system itself. Modern detection and tracking rely on discrimination, separating meaningful signals from background noise. When jamming crossed a certain threshold, that process began to fail. Algorithms designed to filter clutter were overwhelmed by the sheer density of emissions. Instead of suppressing incoming threats, the electronic environment became crowded with reflections, harmonics, and false correlations. Operators were forced to interpret sensor feeds that no longer behaved predictably. The more power was applied, the less intelligible the picture became. Visibility did not disappear, it fragmented. This inversion created a second, more dangerous effect. Strong, continuous emissions provided a reference point in the battle space. Systems broadcasting at high power announced their presence with precision. For attackers equipped with passive detection or homing capabilities, those emissions become beacons rather than barriers. Navigation no longer depends on external signals like GPS. It can be guided by the defender's own activity. In attempting to blind the attacker, the system illuminated itself. The result was a self-inflicted blindfold. Decision makers assumed that escalating electronic pressure would increase survivability, but instead, it compressed their ability to observe, prioritize, and respond. Reducing jamming risked exposure. Maintaining it deepened confusion. This dilemma left little room for adaptive control. Once the electronic environment crossed into saturation, reversing course became operationally costly and psychologically difficult. The episode highlights a fundamental shift in electronic warfare dynamics. Power alone is no longer synonymous with dominance. Precision, restraint, and timing matter just as much. When electronic systems lose the ability to interpret their own environment, they stop functioning as shields and start acting as liabilities, undermining the very awareness they were meant to protect. Electronic warfare is often treated as a force multiplier, a way to dominate the battle space by denying the enemy information. In this operation, that assumption was turned on its head. As jamming intensity increased, it did not create clarity through denial, it generated chaos through excess. High-powered emissions flooded the electromagnetic spectrum, saturating not only enemy receivers but friendly sensors as well. Radar returns multiplied, folded, and echoed in ways that degraded rather than enhanced situational awareness. What was intended as a protective fog became a storm inside the system itself. Modern detection and tracking rely on discrimination separating meaningful signals from background noise. When jamming crossed a certain threshold, that process began to fail. Algorithms designed to filter clutter were overwhelmed by the sheer density of emissions. Instead of suppressing incoming threats, the electronic environment became crowded with reflections, harmonics, and false correlations. Operators were forced to interpret sensor feeds that no longer behaved predictably. The more power was applied, the less intelligible the picture became. Visibility did not disappear, it fragmented. This inversion created a second, more dangerous effect. Strong continuous emissions provided a reference point in the battle space. Systems broadcasting at high power announced their presence with precision. For attackers equipped with passive detection or homing capabilities, those emissions become beacons rather than barriers. Navigation no longer depends on external signals like GPS. It can be guided by the defender's own activity. In attempting to blind the attacker, the system illuminated itself. The result was a self-inflicted blindfold. Decision-makers assumed that escalating electronic pressure would increase survivability, but instead, it compressed their ability to observe, prioritize, and respond. Reducing jamming risked exposure. Maintaining it deepened confusion. This dilemma left little room for adaptive control. Once the electronic environment crossed into saturation, reversing course became operationally costly and psychologically difficult. The episode highlights a fundamental shift in electronic warfare dynamics. Power alone is no longer synonymous with dominance. Precision, restraint, and timing matter just as much. When electronic systems lose the ability to interpret their own environment, they stop functioning as shields and start acting as liabilities, undermining the very awareness they were meant to protect. What ultimately defined this operation was not the destruction of individual systems, but the deliberate disruption of how those systems functioned over time. Instead of concentrating force on a single layer, air defense, logistics, command, or maintenance, the attack moved across them in sequence, never striking the same layer twice in a row. This sequencing mattered more than scale. Each disruption forced the system to react, but every reaction was aimed at solving the last problem rather than anticipating the next one. Maintenance crews focused on damaged equipment just as air defenses were being overstimulated. Air defense units burned through interceptors, while logistics nodes were being quietly disabled. Command elements attempted to restore coherence, while their data inputs were becoming increasingly unreliable. The system was never allowed to settle into a stable rhythm. Military organizations depend on tempo, maintenance cycles, refueling schedules, reload timelines, command updates, and defensive readiness all operate on predictable beats. When those beats align, power is generated efficiently. This operation attacked that alignment. By staggering effects across domains, Ukraine prevented adaptation. There was no opportunity to learn, adjust, and counter because every adjustment arrived too late or addressed the wrong layer. The result was desynchronization. Systems that were individually functional became collectively ineffective because they were no longer operating in time with one another. This approach also avoided the escalatory signals associated with mass destruction. Nothing was annihilated in a single overwhelming blow. Instead, capability eroded as coordination slipped. Launchers waited on fuel that never arrived. Defenses stood alert with empty magazines. Command posts issued orders based on outdated or incomplete information. The system did not collapse violently. It unraveled. By the time commanders recognized the pattern, restoring tempo required rebuilding multiple processes simultaneously, an exponentially harder task than replacing hardware. Victory, in this sense, came from breaking rhythm rather than breaking steel. The operation demonstrated that modern conflict is increasingly about timing, sequencing, and forcing the enemy into a perpetual state of reaction. If you value objective analysis over noise and speculation, consider following this channel. We focus on how decisions are made and the changes they produce. The defining feature of the operation was not the destruction of equipment, but the deliberate disruption of how the entire system functioned over time. Rather than concentrating effort on a single target set, the attack moved through different layers of the missile enterprise in sequence. Maintenance was disrupted, then air defense, then logistics, then command and control, never in a predictable order, and never long enough in one domain for countermeasures to stabilize. Each strike forced an immediate response, but those responses were always aimed at the previous disruption, not the one already forming. The system remained active, yet perpetually behind. Military power depends on rhythm. Maintenance cycles prepare systems to fight, logistics sustain them, defenses protect them, and command synchronizes everything into coherent action. When these processes align, capability scales rapidly. When they fall out of sync, even advanced forces lose effectiveness. This operation exploited that dependency. By preventing any single layer from re-establishing normal tempo, Ukraine created cumulative effects without needing cumulative destruction. Each layer functioned in isolation, but the system as a whole lost coherence. The absence of repeated strikes on the same layer was critical. Repetition allows learning. It enables adaptation, redistribution of resources, and procedural change. By constantly shifting the focus, the attack denied defenders the feedback loops required to adjust. Commanders could not determine whether they were facing a logistics problem, an air defense problem, or a command and control failure, because all were occurring, but never simultaneously. That uncertainty slowed decisions and fractured coordination. The result was desynchronization rather than annihilation. Launchers remained intact, but idle. Defenses stayed online, but ineffective. Orders were issued, but poorly executed. Capability did not disappear in a single moment. It dissolved as timing broke down. This illustrates a broader shift in modern warfare, where success is increasingly defined by the ability to disrupt processes rather than destroy platforms. When rhythm collapses, power follows, not because assets are gone, but because they can no longer act together. What this analysis ultimately points to is something larger than warfare. It is about systems, timing, and the quiet moments we tend to overlook. Strength rarely fails at its most obvious points. It fails in transitions, when routines change, when attention is divided, when we assume that what has worked before will keep working tomorrow. In life, as in complex systems, breakdowns often begin not with dramatic collapse, but with small misalignments that go unnoticed until they accumulate. One lesson stands out. Power is not just what you have, but how well the parts of your life move together. Health, relationships, work, and purpose all operate on their own rhythms. When they fall out of sync, when rest is neglected, when decisions are rushed, when problems are addressed one at a time without seeing the whole, progress slows, even if effort increases. Many people reach midlife, believing they need more force, more activity, more pressure. Often, what's really needed is better timing and clearer priorities. Another insight is the danger of reacting instead of reflecting. Systems under stress tend to chase the last problem they saw, not the one forming ahead. People do the same. We fix what's loud and visible while missing what's quietly becoming critical. Stepping back, reassessing, and restoring balance is not weakness, it's strategic patience. Perhaps the most enduring takeaway is this: lasting resilience comes from alignment, not intensity. When the pieces of a life work together, progress feels steady and sustainable. When they don't, even great effort can feel exhausting and unproductive. The goal, at any stage of life, is not to move faster, but to move in rhythm with what truly matters.